Hello and welcome to this new video. In the previous video, we optimized our code on the player controller side. In this video, we will optimize the game mode side, so we will create a master game mode that will be the parent of all the game modes in our game. This allows us to subsequently manage the sessions on the host side in any map. Thus, this allows us to avoid duplicates each time we create a game mode to manage the sessions. So everything you see in the lobby game mode related to session management can be moved into a parent class. To start, we want to do what we did in the previous video. So, create a new folder in the main menu folder and name it Master Game Mode. In this folder we will create our master game mode and move the game mode lobby interface so that it is an interface of the parent class. Create a blueprint class of type game mode base and name it Master Game Mode. Find and rename the game mode lobby interface, then move it into this new folder. In the master game mode, check that the pawn is set to default pawn. Finally, it is the child class which decides the type of pawn according to the level to play. Set the game session class to none. You can leave the player controller to default player controller. Go to Class Settings and implement the Master Game Mode interface. Open the Master Game Mode interface. We must rename the functions containing the word lobby, because whatever the type of session, it remains a session. It is the parameters provided to these functions which specify the type of session. As we did in the player controller interface, add a new function that returns the reference of the master game mode type class. Go to the lobby game mode and override this new function. We must first reparent the lobby game mode so that it is a child of the master game mode. Go to master game mode and implement this function. I see that the create session function is not implemented in the lobby game mode. It's because of the rename that we did, while Unreal Engine is supposed to replace the references in case of rename. But if you have the same problem as me, just follow me to fix it. Now just delete the node and connect the pins of the new function. Now we need to move the variables that may be common for all game modes to the parent class. Follow me to move them. Right-click on current player controllers, then move to parent class. Repeat the process for the other variables. If you moved via copy-paste, you can fix the renamed variable as follows. Do the same for the number of players. In the case of a move to parent, there is nothing to fix in the child class. We will do the same for the member settings and the player cards variables. The spawned characters variable is specific to the lobby game mode, so we're not going to move it. The same for lobby session variable, because it is the child who decides if it will manage a single or multiple sessions. I want to move the isListening variable because we can listen in several maps. We can move the isLobbySessionValid function, because this check is the same for all game modes. But I will rename it isSessionValid instead. In this function, add an input of type OSS session instead of using the lobby session variable of the child class. Look for all references of this function to pass the lobby session variable as input. Once finished, we can move it into the parent class. This message indicates that if you want to keep the function in the child class or not, you can click on Delete. I want to click on No to show you the difference. Here the function was moved to the parent class, but it was transformed into an override in the child class. We will delete this override. It was just to show you what happens if you do not delete it in case of move to parent. And voila, now the function call points to the parent class. We want to move the register players in session function. It is a common functionality for all game modes. We must first pass the session as input. Then set the references as we did for the first function. You can now move the function. Repeat the same process for the unregistered player from session function. You can now move the function. Again, the same process for the kick all members from session function. We also want to move the update session members function. I just want to check that everything is good. It is recommended to move the tasks that manage sessions such as create session, start session, etc. into a macro in the parent class, but the problem is that the macro cannot be callable from a child class. The solution is therefore to create a blueprint macro library which contains all the macros to manage the session. In the master game mode folder, add a blueprint macro library of type game mode base and name it ml_session manager. In this library, add all functions which are used to manage the sessions by async tasks like create session. Just follow me. Add a category for these functions to easily identify them from a game mode. Basically, these functions are create session, end session, destroy session, and start session. Go back to the game mode lobby to copy the tasks and then paste them into the corresponding macros. Follow me. Connect all inputs to the input node, then all outputs to the output node. In the game mode lobby, replace the task with the macro that we created. You may say that this implementation does not make sense, because the macro contains only the task. It is true for the create session macro, but on the other hand, for the others it is useful because we will add more implementation in each macro. The same for the update session macro, there will only be one task to add. Same, in the game mode lobby, replace the task with the macro. For the start session, we will copy the task and the check which is before. So for this macro, we have an additional input which represents the session for which we will execute the start macro. Likewise, in the game mode lobby, we will use the macro created. The same process will be for the other macros. Here we have simplified the implementation for each game mode that will manage the sessions. We still have the destroy session macro. It will still be the same process. Here we have to make a small modification first. We can move the kick all members from session in the macro. But I prefer to leave it in the game mode, and therefore add in the macro only the task and the check of the session current state. You can reparent the macro library so that it is only callable from game modes of type master game mode. Remove the function from the macro, then call the macro from the lobby game mode. I want to check that everything is good. As I said before, this function should be placed in the game mode lobby, so no need to delay to make sure all members have left the session before destroying it. I want to use another more efficient solution. As I already announced, I will place the call to this function in the game mode lobby before the macro call. Instead of using a delay, I want to assign the event dispatcher that we want to add in the master game mode. Open the function. Then add an event dispatcher and name it on all members kicked from session. Once created, make a call to it when the loop finishes execution. So the event is triggered when all members of the session are kicked. Return to the game mode lobby and assign the event. Make sure to assign it before calling the function, to prevent the event dispatcher call from executing before the bind. We must now proceed to execute destroy script once the event is triggered. Like this, we do not destroy the session until all the members of the session are kicked. I now want to add other event dispatchers in the master game mode, which can tell us that an operation has finished. For example, when the session is started. Follow me and add these events. The on session created will be called when a session is created. The on session started will be called when a session is started. The on session ended will be called when a session is ended. The on session destroyed will be called when a session is destroyed. Return to the game mode lobby and call these events, so when a task executes successfully. If the task returns a parameter, we want to add it to the event dispatcher. For example, in case of creation of a session, a structure of type OSS session is returned, like that we can use it in case of bind of the event dispatcher. We forgot to add an event dispatcher that fires when a session is updated. I'll add it. We still have to make the call for the rest of the events. Just follow me. In a real game, the game code should change the state of a session and not the player. So in the case of start match, we want to change the state of the session from pending to in progress. So we should start the session when the host clicks on the start match button. So here, we want to assign the event on session started, then start the session. And when the event dispatcher is triggered, it means when the session is started. So we will do the server travel. We can connect the name of the map to play. but I prefer to declare the selected map in the game instance, so the host can get it from his game instance. So go to the Home widget. We want to change the code that calls the game mode to start the match. In the game instance interface, add two functions. The first is used to update the selected map in the game instance, and the second is used to obtain it. Now go back to the game instance and implement the two new functions. Go to the Master Game Mode interface and remove the input from the Start Match function. Return to the Lobby Game mode, then refresh the event. We still have this error because we need also to refresh the call of this event in the Home widget. In the Home widget, we need to update the value of selected map in the game instance every time the selected map in the widget changes. Now, in the lobby game mode, we can get the current selected map from the game instance. Now go to the Lobby Sessions widget. I want to disconnect the Start, End, and Destroy Session buttons. For me, these are buttons for dev purpose. Return to the game mode lobby. We have one more function to move into the parent class. It's the check for session updates. As we did for the other functions, add the input. Then fix all references. Because this function will be in the parent class, we must remove the set lobby session. We want this function to return only the updates. Then we can use these updates in the child class. So in the lobby game mode, delete the timer which does the check, as well as its associated variable. What we will do therefore, is to define a timer in the begin play event in the master game mode, which will do the check. Then it calls an event dispatcher when there are updates for the requested session. First go to the function. We want to change the script. The code will therefore be to get session updates from game instance, then call an event dispatcher which takes the updated sessions as parameter. Create an event dispatcher and name it on Session Updates checked. Add a parameter to this event of type map, while the key is string and the value is OSS session. Call the event, then provide it the value returned by getUpdatedSessions node. Return to the event, begin play of master game mode, then create a timer, then give it the name of the function, and check the looping box. Now return to the lobby game mode, then assign the event dispatcher on begin play. When the event fires, check if the lobby session has updates. If yes, set the value of the variable to the updated session. Create a function which does the job. Then call it when the event fires. We will not update the variable if the session is not valid. Normally everything is good on the game mode optimization side. We will launch a test to verify. Create a session on player 1, then join it from player 2. And there you have it, everything works as it should. Nothing has changed on the game side. Except that our backend is now optimized. We will see in the next video how easy it is to implement the game mode of World 1 so that we keep track of the session management. That's all for this video. See you in the next one.